Book summary: Advanced Recovery Optimization, Modern Strategies to Maximize Recovery from Mature Oil and Gas Assets by Anriansyah and Nyoman Witasta. The book is a multidisciplinary framework for improving recovery from mature oil and gas assets, not simply through new technology, but by changing how the entire asset is diagnosed, managed, funded, integrated, and continuously optimized. Book summary. 1. The central argument. The book's fundamental argument is that mature field underperformance is primarily a systems problem, not simply a depletion or technology problem. The conventional assumption is mature field, depleted reservoir, declining production, limited remaining value. The authors challenge this assumption. They argue that substantial volumes of hydrocarbons remain recoverable in already developed reservoirs, but organizations frequently fail to capture that value because of fragmented decision-making, inadequate surveillance, poor capital allocation, organizational silos, weak EOR capability, uncertainty management problems, and ineffective governance. The book therefore shifts the question from what technology should we deploy? 2. Why is the asset underperforming, and what combination of technical, digital, economic, and organizational interventions is required to close the recovery gap? This is the book's most important conceptual contribution. 2. The recovery opportunity. The authors frame mature fields as one of the industry's largest remaining sources of value. They cite an approximate 35% global average conventional oil recovery factor, compared with 50 to 60% or higher in well-managed analog fields. Even a relatively small improvement in average recovery could therefore represent enormous additional recoverable resources. The book's broader thesis is that the industry should not automatically treat mature assets as declining liabilities. Instead, they should be evaluated as brownfield development opportunities with existing wells, existing infrastructure, established production systems, accumulated reservoir data, known operating behavior, and potentially significant remaining hydrocarbons. The authors argue that the value gap between what is technically recoverable and what is actually recovered is therefore a major strategic opportunity. 3. The book's 8-part architecture. The book is organized around 8 interconnected areas rather than treating reservoir engineering, production, economics, digital technology, and organization as separate disciplines. Part 1. The global challenge of mature energy assets. This section establishes the system's diagnosis. It explains why mature fields underperform, the global scale of the unrecovered resource opportunity, and the structural barriers preventing recovery optimization. The key idea is that fixing only one problem, for example, installing better surveillance or introducing EOR, will often fail because the underlying barriers interact with one another. Part 2. Reservoir depletion and recovery limitations. The second part provides the reservoir engineering foundation. It examines a reservoir heterogeneity, a preferential flow and bypassed oil, a pressure decline, a depletion mechanisms, a sweep efficiency, and ways of improving reservoir displacement and conformance. The emphasis is on diagnosis before intervention. The book repeatedly argues that operators should first determine why recovery is poor before selecting an intervention. Part 3. Water flooding, gas injection and EOR. This is the core technology section. It covers a water flood optimization, a pattern-level injection management, a gas injection, a miscible recovery, a co-EOR, a WAG, a chemical EOR, a polymer flooding, a thermal recovery, and EOR pilot design. Importantly, the book does not present EOR as a universal answer. Technology selection should follow reservoir screening, uncertainty assessment, economics, and organizational readiness. Among the opportunities highlighted are pattern-level injection optimization, pre-breakthrough conformance control, polymer flooding, co-EOR, and targeted horizontal infill drilling. Observe, model, optimize, implement, repeat. This is called closed-loop reservoir management, CLRM. The important point is that digitalization is not presented as simply putting AI into the field. Digital twins and AI are valuable because they allow the management cycle to become faster, more adaptive, and more continuous. Applications include a production forecasting, a anomaly detection, a ESP failure prediction, a injection optimization, EOR control,
et surveillance automation.
and eventually autonomous field management. But the authors make an important qualification. AI cannot compensate for fundamentally poor data. Deploying sophisticated AI on unreliable, incomplete, or inconsistent data can produce confident but incorrect conclusions. Consequently, data quality and engineering interpretation are prerequisites for digital transformation. 5. Production optimization, turning reservoir potential into barrels. Part 5 moves from the reservoir to the production system. It covers artificial lift,
Et ESP optimisation.
a workover prioritization, a production system constraints, a produced water management, a gas handling, a facility capacity, air and debottlenecking. A key insight is that reservoir potential does not automatically become production. For example, an excellent workover candidate may produce little incremental value if the facility cannot process the additional water or gas. Likewise, an optimized injection program may be constrained by pump capacity. The book therefore treats the field as one interconnected production system rather than separate subsurface and surface domains. 6. Economics and ESG. Part 6 addresses a problem that can undermine technically excellent projects: capital allocation. The book argues that mature field investments are often disadvantaged because organizations emphasize a short payback, a current year production, annual budgets, and simple project economics. This can systematically favor short-term workovers over longer-term EOR, waterflood optimization, and reservoir management investments, even when the latter create greater full-life value. The proposed solution is a more comprehensive economic framework incorporating a full-life NPV, a recovery factor impact, a uncertainty, a staged investment, a real options, a stop criteria, a carbon cost, and portfolio level value. ESG is integrated into the economics. The book does not treat ESG as a separate reporting exercise. It argues that mature field optimization and decarbonization should increasingly be evaluated together. Examples include a reducing methane, a minimizing flaring, a improving injection efficiency, a electrification, a reducing steam intensity, a CCS, and co-EOR. The book therefore proposes treating carbon cost as an explicit component of investment decision-making. 7. Organizational transformation. One of the strongest themes in the book is that technology cannot fix organizational silos by itself. Subsurface, drilling, production, facilities, economics, and management may all possess high-quality expertise but still produce poor decisions because information, incentives, planning cycles, and accountability are fragmented. The book therefore proposes integrated asset team structures and explicit governance mechanisms. A particularly important point is, better software does not automatically create integration. A digital platform can improve information flow, but it cannot determine who owns a decision, who resolves conflicts, or who is accountable when subsurface plans exceed facility capacity. 8. People remain central to digital transformation. The authors strongly reject the idea that AI will simply replace petroleum engineers. Instead, they argue that advanced digital operations require more sophisticated human capability, not less. Future professionals need combinations of a petroleum engineering, a data science, a machine learning, a Python, a physics-based modeling, a digital twin management, and systems thinking. AI amplifies the quality of the engineering organization that surrounds it. This produces an important principle. Technology and human capability are complements, not substitutes. 9. The future. Adaptive recovery intelligence. The book ultimately brings all of these elements together into the concept of an adaptive recovery ecosystem. The envisioned mature field is continuously aware of its current state, continuously optimizing operations, continuously adapting recovery programs, continuously monitoring carbon performance, and continuously learning from operational results. Its characteristics include 1. Continuous state awareness. 2. Autonomous operational optimization. 3. Adaptive EOR and recovery management. 4. Integrated carbon management. 5. Continuous organizational learning. This represents a fundamental change from the traditional model. Periodic study, annual plan, execute, wait, next study. Toward. Sense, understand, optimize, act, measure, learn, repeat. 10. The book's most important strategic message. The final argument is quite straightforward. Mature field optimization should be treated as a strategic portfolio development program, not merely as late-life production management. The authors argue that extracting maximum value requires simultaneous attention to a reservoir science, a recovery technology, a production systems, a digital infrastructure, a economics, a ESG, a organizational design, a workforce capability, and governance. Correcting only one of these dimensions is unlikely to deliver the full potential. The book explicitly describes this as a multi-year technical and organizational transformation, rather than a technology procurement project. 11. The 10 biggest opportunities. The executive section identifies 10 major recovery opportunities. 1. Close the recovery factor gap. 2. Optimize injection at pattern level. 3. Apply conformance control before breakthrough. 4. Deploy chemical EOR on technically proven candidates. 5. Use industrial source co for suitable co-EOR projects. 6. Target bypassed compartments with horizontal infill. 7. Use digital twins for closed-loop management. 8. Retrofit smart well technology on high-value producer or injector pairs. 9. Allocate capital according to asset maturity. 10. Use net zero EOR as a dual-value strategy. These opportunities are deliberately presented as a portfolio rather than a single best technology. 12. The 10 biggest risks. The book also warns against several recurring failure modes. Allowing short-term budgets to undermine long-term reservoir value. Waiting until water breakthrough before conformance intervention. Underestimating abandonment liabilities. Extrapolating pilot results without checking representativeness. Ignoring future carbon costs. And allowing digital AI pilots to remain pilots without organizational adoption. This is important because the book's perspective is not technology optimistic in a naive sense. It repeatedly asks whether the organization is actually capable of realizing the technology's theoretical value. 13. The 10 strategic recommendations. The executive recommendations can be condensed into a practical management agenda. First, diagnose. Conduct an ARMI assessment across the portfolio. Establish pattern-level VRR surveillance. Second, improve investment discipline. Use realistic P50 assumptions for EOR. Define stop criteria before project approval. Include full-life NPV and recovery factor impact. Third, integrate the organization. Establish formal cross-functional review forums. Integrate subsurface and surface planning. Fourth, prepare for the future. Audit data quality before AI investment. Incorporate carbon cost into capital decisions. Classify assets according to their likely 2035 strategic pathway. Finally, treat organizational failure as a management problem. The book recommends using its catalog of 25 recovery optimization failures as an organizational diagnostic, rather than merely as a technical checklist. 14. Overall assessment of the book. Based strictly on the book structure and arguments, I would characterize it as 3 books combined into one. A mature field technical optimization book. It covers reservoir heterogeneity, pressure management, water flooding, gas injection, EOR, artificial lift, workovers, and facilities. B. An asset management and investment book. It explains how economics, uncertainty, capital allocation, ESG, and portfolio strategy determine whether technically attractive opportunities actually receive funding. C. An organizational and digital transformation book. It explains why AI, digital twins, integrated asset teams, governance, and workforce transformation are necessary to move from periodic optimization toward adaptive field management. That combination is deliberate. The authors explicitly position systems diagnosis before technology prescription as one of the book's distinguishing propositions. 1 paragraph summary.